Here we're going to look at determining key features of a quadratic function. And the question is, what are the key features of the quadratic function f of x equals 2 times the quantity x minus 3 squared plus 4. So remember that that's in vertex form, so we'll use that. Now your key features, you're going to start with the vertex. We will also have the axis of symmetry. That's not how you would write axis of symmetry. Sorry about this. So axis of symmetry. The maximum or minimum. So that's related to the vertex, whether it is a max or a min. Our domain. And finally, our range. Now, those 5 things are listed down here as well. So if you need to figure those out, they'll be there. So one of the first things you should look at is you should label your A, H, and K values. It'll help you with the vertex, axis symmetry, and the range. So that'll come in handy. And I'm just going to put some arrows on the top of my graph here. All right, so A in this case is our 2. K is the easy one, that's a 4. And now your H value, we want to be careful with. H comes from here. We need to think about the formula where it's x minus h. That means that we plugged in an H value of 3. It will be the opposite of what it appears to be. So since we have x minus 3, the actual H value itself is a positive 3. So now let's figure out our key features. You won't always be provided the graph. Like you can see in practice number 3 on the bottom here, there's no graph provided. If you have the graph, it becomes much easier to figure out a lot of this, but we're going to operate as if we didn't have the graph, and we'll just use the graph to kind of confirm. Your vertex, what you want to use for your vertex are the values h and k. The vertex is always hk, so for this specific problem, we would have 3, 4. If we check on our graph, it's clearly at 3, 4. So just remember the vertex, if your graph is not provided, you can just use the h and the k values. We'll highlight all of that in a moment. Your axis of symmetry is the vertical line that cuts your parabola in half, so the left and right sides are equal. In this case, it will be x equals h, and we know that h is equal to 3. So my axis of symmetry would be x equals 3. Do make sure that you state x equals 3. Do not just write the number 3. All right. Next, we have our maximum or our minimum. This is in relation to the vertex, and we want to know whether the vertex is the highest or the lowest point. Well, if we look at our function, our vertex is the lowest point along that red parabola. So since it's the lowest point, we would have a minimum. The only time you would have a maximum is if the graph was reflected. So if you had a graph that was reflected and looked like this, your vertex would be your highest point. So that's when you would have a maximum. Your domain is your x values. For these problems, there's not going to be many exceptions, but your domain continues to go left and continues to go right. So we can state that that the domain is all real numbers. You also, if you want to put it at an interval notation, could say negative infinity to positive infinity. If the domain is the x values, then the range are your y values. So we need to find a lowest and highest point. So we're looking at like a minimum and a maximum. Now keep in mind that our vertex was a minimum. So that's my signal that there should be a number that goes here where the minimum is. And that number is going to be our k value. Because that value is here. We're talking about y, which would be a 4. So our minimum value would be a 4. We're going to put a bracket with that. And the maximum value, this graph goes up forever. So this graph would go up to positive infinity, and you'll always use a parenthesis there. So now a couple of things to be highlighted. Your h value of 3 will be used in your vertex and will be used again in your axis of symmetry. Your k value of 4 will be used in your vertex, and then it will be used again in your range. Now, it might be the minimum or it might be the maximum, but the k value will depend on whether the vertex is a min or a max. So in the case, the opposite of this, where we had a maximum, the k value would have wound up here. Right, in this case, it is our minimum, so we would list it first. That's really how you go about finding the key features of a quadratic function. Again, you will not always be provided the graph, so it is important that you start to figure out and understand your h and k values and how they apply to the key features of the function. A doesn't really matter too much. You could do most of this without it. However, the A does tell you whether the graph opens upwards or downwards, whether it's reflected or not, and that'll help you determine whether there's a minimum or a maximum. All right, that's really it for the key features. So just get some practice with knowing where to apply H and K, and you should be good.